Guys are here. Today we're going to be talking about Ethereum and Ethereum Layer 2, essentially what's happened and what is to come. So by show of hands, how many of you know what Ethereum is or are familiar with it or have heard about it before? Cool. How many of you have heard about decentralized finance or DeFi? All right. And what about Layer 2? All right, so a little bit less. Well, hopefully, for those of you who have heard about it, hopefully I can teach you something new. And for the rest of you, hopefully I can explain some of this stuff pretty well. Let's see. Nope. Didn't want to do. There we go. All right, so starting off with Ethereum. This is a blockchain network that was launched a few years ago, back in 2015. They launched their ICO in 2014. It has now become the most decentralized smart contract blockchain in the world. It's essentially become a behemoth in the blockchain ecosystem. And right now, it's actually settling over $45 billion every single day. And over the last 12 months, this blockchain network has settled over $2 trillion. And as you can probably imagine, the developer community around Ethereum is incredible, and it is growing on a day-to-day basis. And as you can imagine, with the developer community growing, so are the people using Ethereum. This is a chart of all of the unique Ethereum addresses that have created an account on Ethereum. So this is creating a public and private key on the Ethereum blockchain. To date, there are over 150 million addresses created. That does not include all the people who have made different types of accounts on brokerage platforms like Robinhood, Coinbase, etc. These are just unique Ethereum addresses. And with that growth and people using the network, Ethereum has gotten incredibly congested. So by a show of hands, who has made a trade on Ethereum or sent a transaction? It hurts. It hurts your wallet, and you're like, I don't really feel comfortable paying that much. It's been pretty painful. And on the left-hand side, this is a chart showing how much ETH has actually been paid on a day-to-day basis over, I guess, the last 2 years or year and a half. And with some of the spikes, there was over 45,000 ETH paid on a single day for transaction fees to the network. And on the right-hand side is the amount of gas paid to the network. So this is essentially people paying transaction fees to the miners, and the higher that it spikes is the more expensive each individual transaction becomes. And now you're probably wondering, all right, well, all that congestion is great. That kind of stinks because it's hurting my pocket, and I don't want that to happen. How is this all going to scale? So before I can talk about Layer 2, I want to talk about ETH 2.0. And ETH 2.0, you can essentially think about this as an upgrade to the entire Ethereum network. This is also a transition from going from where it currently is as a proof of work consensus mechanism, which is the same as Bitcoin and Litecoin. Those also use proof of work, where it's actually going to transition into a proof of stake consensus. And the process to move into ETH 2.0 occurred in Q4 of last year. And this is where what's known as the beacon chain, which is phase 0 of ETH 2.0, launched. To date, there is, well, I don't know if it's still $13 billion. I made the slides a couple days ago. ETH's been a little volatile the last few days, but when I made this slide deck, there was over $13 billion staked into ETH 2.0, which is pretty incredible. These are people going and launching their own validators, helping to support the network. There's over 150,000 validators spread around the globe. And what is going to be occurring is later this year or early 2022 is when the merge is going to occur. This is going to be the next phase of ETH 2.0. And this is where essentially the beacon chain comes into play. Right now, you can think of the beacon chain as like a highway going right next to I-95. So I-95 is the Ethereum network right now. Who likes driving on I-95 during rush hour? Yeah, not me. It's pretty awful. It's pretty congested, and that's kind of similar to Ethereum right now. And the beacon chain is essentially running in parallel to it, which started in Q4 of last year. And it's just people essentially supporting it and building out that solution. And with the merge, those two quote unquote highways will come together. And the way Ethereum currently operates will effectively cease to exist. It won't necessarily operate as it currently does any longer. It's going to be then transitioning into a proof of stake blockchain. And then the beacon chain essentially takes over, and that now becomes the new network. With sharding, this is going to be coming later in 2022, potentially 2023. And this is where the actual network will then begin to scale horizontally. So the network will be able to scale by about 64 times what it currently is. Right now, it's able to process about 15 transactions per second, which is really, really slow for being one of the largest blockchains in the world. And with the solution, it will be able to scale. And now you're probably wondering, well, all right, well, I don't want to wait that long for ETH 2.0 to launch. So what is this layer 2 crap? What does it mean? What does this mean to me? On this picture, I have a picture of the skyline of New York City. You can think of layer 2 solutions similar to big city hubs, like Miami, like New York City, like LA, like Vegas. Imagine what these cities would look like if there were no skylines, if everything was just flat, just a single story building. Wouldn't really be the same cities that we know and love today, would it? It wouldn't be. All these cities, they've essentially built up vertically to support all of the congestion, all the people living in these areas. And that's essentially what layer 2 solutions do for Ethereum and for just different blockchain networks in general. It allows you to scale vertically. So different types of layer 2 solutions are able to be built on Ethereum, for example. They're able to be built and deployed on Ethereum. We're able to take all this congestion from different types of solutions and put them into one instance where all that economic activity is able to occur much more effectively and much cheaper cost. Oh. Don't know what's going on there.
It's a VPN.
I'm breaking things, apparently. There we go. I'm just not going to worry about that. So, as you can imagine, the layer 2 ecosystem it's expanding dramatically. And I'm proud to say, like, our team is one of those innovators. We're actually like right there in the middle. You want to see us? There. And like our team, we are building the application layer on layer 2. So people like yourself or me, you're able to interact with Ethereum layer 2. And all these teams and organizations, they're helping to build out this ecosystem. And this list of companies is going to grow exponentially over the next 3 to 6 months. Like, I will not be able to put all the teams that are going to be in this picture within 3 months. I can guarantee that. And so you're probably wondering, okay, well, layer 2 is cool. What does that mean? And what are the different types of solutions out there? There are a few, and they all have different types of pros and cons, security guarantees, different types of throughput. The 3 main ones that we're actually going to be talking about today are the top 3. A zkRollup, which stands for a zero-knowledge rollup, an optimistic rollup, and Validium. The other 2 solutions out there right now are Plasma and state channels. Realistically, Plasma does not have that much functionality at the moment. There's not that much development going around it, so I don't want to bore you guys with the details around it. State channels are being used, but it is more of a middleware type of solution. It's not something that you're going to be interacting with on a day-to-day basis. So we're going to be talking about those 3 main pieces, which is a zkRollup, an optimistic rollup, and a Validity. So when we're breaking down these solutions, They can be broken down into how different types of transactions are generated or proofs are created, and how data is being stored. Because right now, if you use the Ethereum network, transactions are essentially generated by using your signing key, and you generate a transaction hash, and obviously all data is on chain. But before we go into these individual solutions, we're going to explain the difference between data being on-chain and off-chain, which otherwise known as data availability, versus the difference between a fraud proof and a validity proof. So first, I'm going to start with data being on-chain versus off-chain. Let me see if I can do this. All right. So, and this all comes down to how data is being stored. This is data availability. When you're going on Ethereum, all data is always going to be publicly available because all data is frankly stored on Ethereum. Obviously, it's not available if the Ethereum network goes down or gets hacked. Thankfully, that's really never occurred. There was a situation back in 2016 where people in the Ethereum community essentially agreed to do a reorg on the network due to a hack in its very early stages. But since then, there has been no mishaps with the Ethereum blockchain at all. It's extremely mature, similar to the Bitcoin blockchain. And when we're talking about data being on-chain versus off-chain, in some of these solutions, that data availability is able to be stored onto the Ethereum network. And in some cases, it's able to be stored off of the Ethereum network, similar to like on AWS. And having those differences, these differences can have varied amounts of security guarantees. Obviously, when you have data being stored on-chain, so it's stored on Ethereum, you have much higher security guarantees, but costs are generally going to be more expensive. And when data is stored off-chain, your transaction throughput is significantly higher, and the cost is much lower. And now let's talk about the difference between a validity proof and a fraud proof. So who here likes watching football, soccer? I played lacrosse in college. Anybody here like watching sports? I'm definitely one of those people. So in sports, you have referees. They essentially review everything that is going on within a game. And I'm going to explain a scenario in a game of football that could potentially occur. It happens very frequently, and how it relates to a fraud proof. So let's say we got a quarterback, Tom Brady's dropping back to pass. He throws and the receiver catches it. It could have been an incomplete pass, but the refs on the field, they rule it as a catch. And the coach on the other side is like, no way, that's not a catch. I'm gonna challenge that. So the refs come together like, all right, we got to review this now. This kind of stinks. And they have to go together. They have to review the play. And that's very similar to a fraud proof. Because when a fraud proof is generated, they have this thing called a dispute time period. And during that dispute time period, people who are guardians, similar to a referee, go and essentially dispute and review all the data that has been generated from that proof. So they're essentially playing their own little mini sports game. With a validity proof, it's fairly different. The proofs are generated in I guess on the output they're very similar, but the way that they're generated is a little bit different. Think of a validity proof in a sports game where you have no referees. So you're playing a game of football or game of lacrosse or soccer, and you don't need referees. All, I guess, plays on the field, you know what the outcome is regardless. You don't need anyone to go and review anything. Everything is true and valid. So that pass was thrown, you don't need any refs to review, it was a catch. It was just known that it was a catch from everyone seeing that occur. And you don't need anyone to review it or trust that it's valid because it's essentially done through cryptography and math in general. So those are some of the differences. With a validity proof, you can know with full certainty that any data that is generated is true and certain. With a fraud proof, you have to essentially review and make sure that the data that's been generated is, well, similar to a validity proof, true and valid. Because if it's not, then you have to sort of backtrack a little bit. So now let's go and talk about how these solutions sort of operate with a zk rollup and an optimistic rollup. These are some of the, I guess, two main solutions that are being used at the moment, and the way that their infrastructure operates is fairly similar in the terms that they're both a rollup solution. So how does a rollup solution actually operate? Who here has flied on a plane or taken a train recently? All right, how easy would that flight have been if you had to take a private jet? It would be kind of expensive.
Much simpler.
Some people, yes, it would be a lot simpler, but you can think of a private jet or going on a train and just essentially renting out the entire train to yourself. You can think of that as sending a transaction on Ethereum. You can do it, but it's expensive. With a zk rollup and an optimistic rollup, and frankly with Validium as well, you're able to essentially bundle all of these transactions together, similar to like a commercial airline or going and taking the metro, for example. And all these transactions are bundled together and then stored onto Ethereum. So similar to like a commercial jet and a private airline, you're still going to get to that end location. The security of those airlines are probably going to be fairly similar, and you're going to get to that end location. Just with the commercial airlines, they're going to be a lot cheaper. So now let's sort of compare how these two solutions, or these three solutions, actually operate. With a zk rollup, they frankly have the highest level of security, or security guarantees. And you might be wondering why. A, because they use validity proofs. You know that any transaction that is generated on a zk rollup is immediately true and valid. It also has on-chain data availability, meaning all data that is generated on a zk rollup is all stored on Ethereum. And that's actually the same with an optimistic rollup, where you have all that data being stored on-chain, but you are using essentially a fraud proof. So the guarantee of that data being true and valid, you can still say it's potentially true and valid, but you just have to review all that information. With a Validium, it generally has a lower security guarantee, but you have the highest throughput and the transaction fees are basically at a minimum. I don't want to say that with a Validium infrastructure that security is always going to be the lowest, because you can essentially think of it similar to a side chain where you could potentially have higher security on a Validium than a zk rollup or an optimistic rollup, but we probably won't see that for a while. So for now, we're just going to say it essentially has lower security guarantees. With a zk rollup, they have about 2,000 transactions per second. An optimistic rollup, they have about 500 transactions per second. And with Validium, frankly, it can scale to close to infinite TPS, which is pretty cool. All these solutions technically are non-custodial, though with Validium, you could potentially have your funds frozen by a quorum of the validators on this implementation. So are you able to withdraw your funds? Yeah, but if they essentially come together and say these funds are frozen, your funds might be stuck. With a zk rollup and an optimistic rollup, that is not possible. And then one of the biggest benefits that you will see, obviously, with an optimistic rollup right out of the gate is that it's fully EVM compatible. We actually just had the first EVM compatible optimistic rollup launch about 3 weeks ago, which is really exciting. So the team at Arbitrum, you can see their logo down there, they launched the first EVM compatible layer 2 solution. Frankly, if you were using a layer 2 solution or someone that dubbed themselves as a layer 2 solution before the end of May, chances are it probably wasn't on the technical side, a layer 2 implementation. And with a zk rollup, it is currently not EVM compatible. Right now, it frankly just supports token transfers. But obviously, you're probably like, well, that's kind of stupid. I wouldn't want that. Well, the good thing is the team at zkSync is actually launching the first EVM-compatible zkRollup in the next couple months. Our team is actually building on zkSync. One of the other zkRollup implementations out there is Starkware. They launched a Turing-complete zkRollup solution. Sorry, I'm not going to get into the technicals of that, so I'll take a step back. But then with Validium, they can support smart contracts currently. So Validium is actually live at the moment. It is not EVM compatible, meaning you can't take any existing Solidity smart contract like Uniswap, Compound, Aave, etc. You can't go and take those onto Validium. At the moment, you can only do that on an optimistic rollup. You'll be able to do that very soon on a zk rollup. The big downside with an optimistic rollup is you're using essentially fraud proofs, but also this challenge period. So when I mentioned back in on this slide where there's referees, you're dealing with something called a fraud proof, and this is the way that transactions and data is generated on an optimistic rollup. And while its name is optimistic, it's not probably the best description of what it does, because you're actually pessimistic about all data that is being generated. So if I'm a validator on an optimistic rollup and I push out data, you all essentially as a community need to go and review and ensure that that information is true and correct. Because if it's not, I could potentially be trying to attack that rollup and potentially try to steal the funds. And when you are trying to withdraw your funds from an optimistic rollup, you have essentially this challenge period, this wait period, which is actually 1 to 2 weeks, which from a user experience perspective, it's pretty brutal. With a Validium and a zkRollup implementation, you can essentially withdraw on the next Ethereum block, so within like 15 minutes. For most withdrawals, it'll take like 4 to 6 hours, but if you would like, you can essentially withdraw right away. With an optimistic rollup, that is not currently possible. There are solutions that are in development to allow for instant withdrawals, but that requires a significant amount of liquidity and market makers providing people to withdraw instantly. So those market makers providing liquidity, they essentially take that liability that there's nothing going on. And then the final one is with a zkRollup and a Validium, you really don't need to have any type of liveness. And what I mean by liveness, this is essentially, okay, if there's things going on within the solution, I don't need to actually overview what's going on. With a zkRollup, you're using validity proofs, similar to a Validium. So any data that's generated, you know right away it's true and valid. With an optimistic rollup, you essentially need people guarding those solutions. And with all of this, I guess, in mind, we're essentially moving towards what's known as a rollup-centric version of Ethereum. Frankly, because all of the economic activity that's occurring on Ethereum right now, it's not going to live on layer 1. It's never going to be able to scale to the amount of demand that it needs, even with ETH 2.0. Because there are so many people that are trying to access this type of technology. Like for people in first world countries like ourselves, we're able to essentially gain higher yield on our assets than, frankly, any bank in the world. With people who are in developing countries or underdeveloped countries, you can basically have access to financial solutions that you can't anywhere currently, which is really powerful. And going and taking all these solutions and putting them onto one blockchain, it's not going to happen. It's going to be frankly, it's going to be a multi-chain, multi-layered world. And within Ethereum, pretty much all of the economic activity, whether it's like yourself, me, it's all going to be existing on layer 2. Why? Because it's faster, the user experience is better, it's cheaper, and even as ETH 2.0 rolls out, that actually benefits all these layer 2 solutions, specifically a zkRollup and an optimistic rollup. With those solutions, they actually scale to over 100,000 transactions per second. And gas costs are even lower. So pretty much all retail activity, it's all going to be existing on layer 2. Some of the things that need to occur for these types of things to happen, for this type of technology to scale to millions, potentially billions of people, is we need more applications supporting this type of technology. Thankfully, I'm proud that our team is one of those innovators. We were essentially spearheading some of this technology. We launched the first mobile application supporting a zkRollup, and we're very proud about that. But we want to see more people doing the same thing. We want to see more innovators out there that are essentially saying, this is how this is going to tap into millions, if not billions of people around the globe. And it also allows for people to essentially scale without sacrificing security. Because right now, the main way that you're able to scale is by going on to a sidechain. A sidechain is, some of them are being regarded as layer 2 solutions, which there can be a lot of back and forth as to whether they are. But when you do that, you're sacrificing a lot of security guarantees. Because what a lot of people don't understand is if you're moving away from Ethereum, you do not have the same security. So if I'm moving from Ethereum into blockchain XYZ, if blockchain XYZ goes down, it gets hacked, blocks stop being produced, sort of the list goes on about potential attacks that could occur. Your funds, frankly, all the funds on blockchain XYZ are at risk. And that's not something that a lot of people really understand. And it's not something that people will understand. Hopefully it never happens. But if it does, that's really when people do start to be like, oh, that makes sense. We need to essentially be regarding security as a very important factor with scaling. And one of the other big things that we really need to see is the ability to move funds between different types of layer 2s. Like I mentioned, it's going to be a multi-chain, multi-layered world. There's going to be multiple layer 2s. There's going to be multiple implementations of them. And the ability to say, similar to Miami, Abu Dhabi, New York City, the ability to essentially move between those locations without having to go back to Ethereum is incredibly valuable. Because there's a lot of people in developing countries, let's say I want to move from a layer 2 implementation, let's say zk Sync, back to Ethereum. The fee to do that over the last couple weeks has been $5 to $10. And for a lot of people, that's a lot of money. That could be a month's salary just to say, I want to move back to Ethereum. And all these people, they're going to want to move directly between these layer 2 solutions, whether it's these specific high rises. And the ability to do that, it's live, but it's still essentially being built out and growing. So that's essentially, I guess, where Ethereum is currently, where it's heading, and obviously, I'm sort of biased. I'm building in the Ethereum ecosystem, so I'm very excited about what's going on. But if you guys have any questions, feel free to let me know. I don't know how much time I have, but if there's a mic or something, I'm more than happy to answer any questions before the next person comes in or after the talk. So, thank you. Do I need to pass a mic around? I'll pass a mic around. It'll probably be easier.
Hey, I'm a PHP Drupal developer, but I want to get into programming Ethereum. What would you recommend as the best track to get into that?
Sure. So programming within Ethereum, I guess it depends on what part of the stack that you want to build. If you're looking to actually build smart contracts, that requires a knowledge of a coding language called Solidity. Solidity is, frankly, the most popular smart contract language out there because of the Ethereum ecosystem. So if you're trying to learn how to deploy, build Solidity smart contracts, there are some great tools out there. One of the ones, I'm not very good at it, but I've done a couple of the basic lessons, and you can do it for free using a website called cryptozombies.io. So it's cryptozombies.io. And you can go on there and you can begin to learn how to essentially code in Solidity. There are different types of smart contract languages out there. Frankly, if you are looking to build smart contracts, I would say start with Solidity, because if you're looking to deploy on any other blockchain, they're going, at some point in the future, if they don't currently, they will be supporting Solidity, just because the developer community around Ethereum and Solidity in general is so vast. So if that's the only, I guess, smart contract language that you know, you'll probably be fine there. Anyone else?
Feedback on that question. So you're
Mark,
talking
last
about
question,
Solidity. If you want to interface with that language or making the smart contracts, could I make an app, maybe anything else, to call that Solidity
Correct.
language? Okay. So
Yes, so that's like essentially like for our product, we actually don't write Solidity smart contracts. We're essentially just an interface that allows you to interact with those smart contracts. So like for us, we're the user interface, user experience to interact with a blockchain or interact with layer 2. So you don't necessarily need to know Solidity or frankly need to know any type of coding language at all. Where if you're just clicking a button, you're signing a message, you're signing with your private key or signing with your signing key. Or if you want to withdraw your funds from a layer 2, you just click withdraw and it's essentially doing all that work for you. So in that case, you just have to build essentially a front end for it. The beautiful thing about how a lot of these blockchains work is if you're building a fully decentralized application, otherwise known as a dApp, in many cases, you don't actually need a backend, because all that data could frankly be stored on chain, because that's what Ethereum does. That's what a blockchain does. It's essentially a database. It's a distributed database. Obviously, providing better user experiences requires having a backend built and having servers. But in the reality of things, you don't really need one, which is cool, because Ethereum and other blockchains, they do that for you. So realistically, if you're trying to build out an application that interacts with Solidity, you just need a front end for it. So you can use just any front end language that you know. I think that's all the time that we have before I get yelled at.
Sorry guys, I gotta cut Mark off here. I've got another speaker waiting to entertain you.
Thank you all for your time. I appreciate it. I'll be sort of mingling around if you guys have any other questions. So, thank you.